Given that the average velocity is equal to the change in position over change in time, if we let x equal change in position and t equal change in time, we can solve for each variable. So starting with the initial velocity, we get this. So we have to multiply 2 in the x, and then divide by t, and then subtract the vf to get this. Same procedure to solve for v sub f, and then to solve for time, here we can multiply again 2 in the x, and then divide by the sum on the numerator, so we get that. Now to solve for v sub I given the acceleration, we can multiply both sides by t, and then we're going to have to negate the negative v sub I to solve for v sub I. And then the v sub f, same procedure, but this time we're going to have to add the v sub I to isolate the v sub f, and then to solve for time, we can multiply both sides by t and then divide by a. So then equating each variable, so starting with the initial velocity, we have this over here, equating the initial velocities and solving for x. Well, how do I solve for x? Well, we can add v sub f on both sides, and then we're going to have to divide by 2 at the end, but first we multiply by t on both sides. So that's where this t comes from, and that's where this t squared comes from. So isolating the x, we get this. Same procedure for v sub f. So equating the v sub f's, and then solving for x. So solving from x from here, we get this. Same procedure. Now for solving for the x using the times, we get this. So of course cross multiplying and then dividing by 2a to isolate the x. So we have these 4 equations for the displacement or the change in position given this information.